Here's a Desmos tricks to help you save time on the SAT. Let's get into it. So we're given an equation here, and what I want you to realize instantly is that we're given the quadratic and we're given a factored out version of the quadratic. And I want you to notice k. And what is k? Well, k is actually your greatest common factor. And something Desmos can do for you is just find your greatest common factor. So our k value is actually equal to 3. So there we go. And instantly from this, we could just tell Desmos our equation. So let's just type that up. And something about Desmos regression is you can't use x, y, e, or r because it's used for different functions. It's really just syntax things, so I'm going to use the subscript 1. And something else I want you to take a look at is that x subscript 1 is equal to 1. So this expression is equal to this expression when x subscript 1 is equal to 1. But we want them to be equivalent expressions, right? We want them to be equivalent for all values of x. So we're going to define it by multiple values so that Desmos understands that these are true for all values of x. The general rule of thumb is the number of unknowns plus 1. And now knowing that, we are looking for our variables as integers though. So usually you'll probably hear me say you shouldn't use a slider, but because we know they're integers, we can use a slider. So what I'm going to do is I'm going to define our step as 1, which means when I use the slider, it's going to go up and down increments of 1, and I'm going to slide until all my variables are integers. And then there we go, they're all integers. And we're looking for the smallest possible value of a, b. And if you take a look at the factored out version, ax squared plus b is really the same thing as cx squared plus d. So while we know ab is 45, cd is 14, and cd is our actual answer. And the reason why that is because you have to understand that these are really like equivalent to one another. AB could have been 14, right? And CD could have been 45 because they're written in the exact same format. So that's why it's asking for the smallest value of AB, because there are actually two values that AB could have been, 45 and 14. So what's the smaller value? 14. So there you go. There's your answer. Thank you for watching. I hope this daily problem helped. I'll see you in the next one. As always, happy studying.